All right, everybody, so we should be live now. We're just going to give it a second to see if some of our viewers come back and rejoin us for this live webinar. Just bear with me for one moment. We're going to check on it on YouTube, make sure that it's all good, and then we'll go ahead and start up. So just bear with us for a second. We apologize about the technical difficulties. But it looks like we are back, and yep, and we're live. And so, all right, well, we got one of our viewers back so far. Hopefully some more pop back on. We're gonna go ahead and get going. I wanna be careful with Shawn's time. So everybody, this is Dan Bigman from LearnGPR.com. And again, like I said in the beginning of the other attempt at this, what I'm trying to do is raise the standards for everybody who uses ground penetrating radar for a whole bunch of different industries, right? It's relevant for archaeology, it's relevant for civil engineering, it's relevant for environmental applications, it's relevant for forensic applications, and so much more. Forestry, agriculture, and so forth. And so our whole goal is to lift everybody up, okay? To teach everybody who uses this technology something that they didn't know, because you can always be better. So that's what we're trying to do. And if you're on this now, subscribe to our YouTube channel. We're going to start doing interviews like this, getting it right the first time. Going forward, we're going to try to do them as often as we can so I can bring on great guests in order to give their background, education, and information that they have developed through their careers to help everybody else out there. So today, we are on the interview with Shawn Patch from New South Associates, and he is somebody who I've admired for a really long time. I've admired his work and Sarah's work, who's generally his partner in crime when it comes to geophysics. And so Shawn is from, he's up in North Carolina, and he's been doing this for a long time. He has been using geophysics for probably a decade plus in archaeology, helping preserve the past and helping archaeologists, identify targets of interest, so you can minimize the effects that they have on archaeological sites, right? The destructive effects. Archaeology is a destructive science. And so one of the things I loved about geophysics when I first came to archaeology was that you can use this technology to help preserve the past, but also learn about it. And so that's why I really liked it. So Shawn, why don't you tell us a little bit about yourself, about your background and your career, and kind of what got you into, ground penetrating radar.
Sure. Well, Dan, thanks for the opportunity to talk today. I've talked a lot in the past, and I always enjoy our conversation. Great to have a chance to talk about my background a little bit. I got involved in geophysics when I worked at the Georgia Department of Transportation in the early 2000s. At that time, I had been there for a couple years, and I was in on the ground floor, so to speak, when GDOT began thinking seriously about acquiring its own instruments to conduct its own GPR surveys at that time. That was in late 2003. In early 2004, the department went ahead and made the acquisition, and all the staff archaeologists at that time had the opportunity to get trained by the folks at KSSI then initially on how to run the equipment. And then there was some subsequent training a few months later from Larry Conyers at the University of Edinburgh, who has literally written the book on GPR and archaeology. So
yeah, or
that
four.
Was the yeah, 4 now, right? He's up to several now. Yeah. So my initial exposure was limited to that professional development. And then from that point on, I was basically on my own in terms of running the instrument as often as I could. And it wasn't just me. There were other folks at GDOT who at the time also had a strong interest. And basically our approach then in those early days was we took the GPR out as often as we could on as many different types of sites and projects as we could to learn how to get better at it. And in those early days, we made a lot of mistakes. We learned some tips and tricks on how to make survey more efficient. We had some ability to learn how to process data and make interpretations. And one of the benefits of being in that environment was that the pressure was low in terms of having to worry really in detail about billable hours or where does every hour of my day go. We were able to take that experience and really learn in an environment that allowed us to make mistakes. Not that I would encourage anyone to deliberately make them, but learning no matter what environment you're in is a process, and it does involve making mistakes. So in those early years, we did make a lot, got better at it, and my experience really has been on the job, essentially. I have learned from applying geophys on a regular basis on a number of different projects and site types, And on my own, as I've developed in my career, I also keep up with the literature. I attend professional conferences. I'm familiar with colleagues like yourself and other people, and we have conversations. So I keep up with all the advances in where geophys is, and that's basically how I got started. And then for the past 10 years, I have been with New South Associates, which is a private consulting firm. And I came to New South with that GPR background specifically. And then since I've been here, we've just slowly built a program that incorporates geophysical survey into our larger preservation activities. And so a lot of the work that we do today is with existing customers with whom we have relationships, where they may want some kind of archaeological work done, and either we can propose doing GPR or geophysics more broadly, or they might request it. And so that's really led to us expanding significantly. And several years ago, Sarah Lowry, who I know you know, joined our staff, and since that time, she and I have been off and running. So we stay fairly busy.
Nice. So I want to move into, you bring up a couple things there that I kind of want to address over the rest of the interview, right? Number one, dealing with government agencies is sort of its own little universe, and it's hard sometimes, I think, if you're not used to it, but you're trying to reach out towards them, because there's a lot of government-owned land. And so there's a lot of times that you'll be in the situation where you have to deal with a government agency. So I want to touch on that. I also want to touch in, like you said, the early years, you kind of make, some mistakes, or there's a learning curve, and maybe you can give folks a little bit about what's aware. But something that came up that I was thinking about is, how critical, just kind of before we move on, now that you've been at New South, right, 10 years, Sarah has been there for how long?
She's been here for 8 or 9 years, I think now. It's been a while. Okay,
for 8 or 9 years. And so how critical has it been to have somebody else on your team who's really well-versed, so it's not, a one-person show? I mean, for the first year or two, were sort of you running the show and you had to grab whoever you could from the, to take into the field? Is that how it worked at first? Or, kind of walk us through that. And then what was the difference once you got Sarah on board and now you guys can sort of, you know each other, you have a process, how critical is success for having, that team as opposed to kind of doing it, all on your own?
Yeah, well, those are good questions. And initially, when I came to New South, it was just me. I had the experience when I was here, and we had a couple of projects early on where I knew GPR would work well. There was a cemetery and another project, and so we applied it then, and then we realized fairly quickly that there was a market for it, but an untapped market, so to speak. And so one of the things I did for those first few years was help establish a market in our area. That's North Carolina specifically, but the broader Southeast as time went on. And initially what I did was some freebie work where I would go out and go to somebody I knew who might be interested and say, look, we have this equipment, we have this technology, we'd like to show you how it works to see if it's something you might be interested in the future. So I did a lot of that type of work early on, again, to further my own experience, but to let folks know that the technology is there, and if it's done right and done by the right person or the right people with the right qualifications, you can get very good results in most circumstances. So that's where it started, but as a result of that, it's a good problem to have. I got so busy that I couldn't keep up with the projects all on my own and fulfill the other responsibilities I also had at that time. And our program was growing, and the next logical step was to bring in someone else who had similar background, similar experience, and more importantly, an interest in doing that primarily. And Sarah worked out real well because she had moved to North Carolina anyway. And so she joined us, and for a number of years, she and I worked together on projects. And during that time, we both came from very different backgrounds. She comes from an academic background as one of Larry Conyers' former graduate students. So she came with that experience. And as I said earlier, my experience was more in the applied realm, and that I learned on my own, primarily and from doing readings and keeping up with the literature. So when the two of us got together, we had different approaches about how we looked at geophys and how we looked at specific sites. And there was some headbutting initially, not in a bad way, but we did each argue that our way was the better way. And the end result of that was that we developed a system that works very well for both of us and that fits our needs here in New South. Something specific, an example might be the survey forms we use. We have the data on there that we know we need to collect. We use those all the time now. It's just an easy way for us to track what's going on and provide that at the end of a project to a customer if they need it. So, but I would say that in the big picture, Sarah and I not only work well together because we get along well and we like each other, we respect each other, but we also have different backgrounds that do complement each other very, very well.
Definitely.
And we have equivalent experience in terms of the number of years we've been doing it, but we function very well as a team now, which is great.
Yeah, it's phenomenal. I mean, it's great to have somebody who you can count on. I think that's sometimes a struggle. If they don't understand what what the ultimate goals of the team are, it can be very difficult. But so kind of transferring into dealing with government agencies, I do have one other question, which I think applies to going after government agencies and trying to get them on board. You said 10 years ago when you were first doing this, you were going out doing freebies, right? First of all, it was for your own benefit, which is great, but doing the freebies was almost like you had to show them that you can locate something that's there, or give them high confidence that there's nothing there, or you can guide excavations or help them sort of identify graves, because the popularity of GPR wasn't nearly what it is today at that point. So now, do you have to overcome the same objections when you're trying to do GPR work with new customers or existing customers, that you had then? And kind of, how, as you do that, as you go out now and try to convince, I guess, people that the technology is useful, which it obviously is. And I think that part of the problem, we've spoken about this in the past, is that sometimes you get people who use the technology but who don't really understand the technology, and so when they're overpromise and underperform, people sort of get a bad taste in their mouth for the technology as a whole. But like you said, it's a lot about a lot of it's about the actual user of the technology, not the system. Right? The system works; it does what it's supposed to do, and sometimes it's hard to kind of express that to a client, an agency you're working with, or a potential prospect. So has it changed from that point till now, as far as people, finally getting that, yes, it's good, it's important, and they recognize it's the technician? And then how has that sort of helped, or, what has been the experience in going after newer contracts with governments like the TVA, with the massive project that you guys did over in Hawaii Island?
Yeah, I would say it is a little different today than it was 10 years ago, in that because people are generally more aware of geophys and what it can and can't do, and that's a result of archaeologists in particular seeing a presentation at a conference, or reading a technical publication, or reading a professional publication. There's much more of an awareness today than there was 10 years ago that the technology does exist. I also think there's an awareness today that it does work. I mean, you made a point that the instrument, or the instruments, always work, and they do. What it comes down to is, does the practitioner understand the site conditions? Does he or she understand the instrument limitations? Does he or she understand what types of features we're trying to image and detect? All of those factors are really important. And so I look at folks we deal with today, and I try to educate them in an informative way to say, this is what the technology can do. It does have limits. There are certain things it can't do in certain conditions, and be very honest with them about what they should expect if they want to pursue some kind of geophysical survey.
Gotcha.
And so that's the approach I take today, is to educate folks. And we, as Sarah and myself, give lots of presentations at professional conferences and regional conferences on the work we've done, not just to show that we can do it, but because that's part of the education process. It's part of the outreach to let the larger community know that if this technology is applied in the right circumstances by the right people, you can generally get very good results. That's the approach we take. So,
all right. So, talk a little bit about that. In how did the project in Tennessee, the TVA project at Hawaii Island, how large was that project, first of all, like in actual geographic space?
That's a big project. That was roughly 150 acres of geophys survey. So it's large scale. Obviously, it's landscape scale. And as you know, Dan, and maybe others as well, that 10 years ago or 12 years ago, when Ken Kavami published his paper in American Antiquity about landscape archaeology and geophysics, at that time, if I recall correctly, he defined large scale as 5 acres or more. 5 acres today, not just for us, but for many other people, is fairly small scale. We've advanced quite a bit in that time frame. So Hiawassee was a very large one, and it's complicated.
And what'd you do in addition to GPR? Because I think you guys did multiple sensors. I know you did the magnetometry too. Did you do anything beyond the magnetometer and the GPR?
Yeah, we did. Well, we started out by doing a full-scale mag survey of the entire island, so that was the main thing. And the GPR was much more focused because, as most of you folks know, it's time and labor intensive. You can't cover as much ground in the same amount of time as you can with a magnetometer. And then we also did some sampling with an EM. We had Eileen Ernenwine, who's a colleague of ours, come down and spend some time with us. And there were some known features that we were aware of, where we wanted to see how well EM would image those and what kinds of data we could expect, because it's not a technology we use routinely. We're aware of it, we know how to do it, but we don't use it on a regular basis. So because we knew we had very well-defined features there, we wanted to take a look at how that instrument in particular would operate and what it would tell us. And we also had Sarah Gale, who at that time was with GSSI, come down and spend a few days with us with GSSI's dual frequency antenna in their digital system. So she was able to collect dual frequency data over, again, some known features, which helped GSSI because they didn't have a very good archaeological example of where that had been applied, and it helped us because we got to see what digital frequency or digital data looked like. So it was kind of nice for that.
Yeah. And I have actually used that system once on an archaeological site where we basically, used the 300 megahertz antenna portion of it in order to map layers in a mound, which apparently was a woodland and a Mississippian mound, but then became a Cherokee, townhouse on top of it. And I was very, surprised, not that I didn't expect anything, less or whatever, but I got great results too from that. So it is it's going to be interesting to see where it goes in the future with the digital antennas, and just the quality that they can produce, along with the depth that they can get, because apparently, from my understanding, is you can get greater depth with the same antenna frequency if it's fully digital, just because it's going to hold up, the signal for longer, or at least the resolution's different, right, than the old analog signals. So my next question then to you is, how'd you get, right, I mean, you're talking 100 and something acres, right, 140 something acres, you said? How did you get them on board to cover that? Because sometimes I think people find it can be frustrating dealing with governments who really want to be tight-fisted. And most people do, right? Very few people really get the benefits when you go big scale. I mean, we were talking before about, how much more you get when you can enlarge a project. If you took every acre and you conducted the survey, each of those acres is not worth the total sum, right? Even if you have them all together, because the perspective you get on such a large scale survey, it really is landscape, has emergent benefits, I feel like, that you don't otherwise get. So how were you able to, I guess, convince, right? How were you able to convince TVA, or sort of make them see the vision of why doing complete coverage of that site at 100 something acres? How'd you get them on board with that kind of large scale vision?
Well, it's a great question, and I'm gonna give you this answer I've given when I get asked this question, or I've been asked this question recently, which is TVA, to its credit, is one of the few agencies, if not the only one, and it is the only one I know of personally. That's not to say there aren't others. It's the only agency that I know of that is applying geophysical survey for archaeological questions at a large scale on a routine basis. There may be others. I don't work in the western part of the U.S. Maybe the BLM does, maybe the Park Service does out there. But in terms of the East in particular, TVA is the only agency I know that does that routinely. So we have done some previous work for TVA on a couple of different Mississippian sites. They were aware of what kinds of results we were getting. We have published a couple of papers on some of the work we've done. And it wasn't a hard sell. In fact, they approached us about it. They had a management concern with Hiawassee Island specifically, in that they wanted to nominate that to the National Register of Historic Places. And they had a draft nomination that had gone to the Tennessee State Historic Preservation Office for review, and it was returned with some comments asking about physical integrity of the site. And there were some staff there who weren't convinced necessarily that Hiawassee still possessed intact features. And so TVA said, well, let's supply geophys survey. We know what it can do. They had seen other examples of it at that case, and they asked us to go out there and do that survey, which we did. And as it turns out, Hiawassee, as an archaeological site, is very, very well preserved. Almost all of the features are still intact. The bulk of the Mississippi Village is still there. And we got very, very fine resolution on the feature types and the feature density. And as a result of that, we made a recommendation in our technical report to TVA that site was obviously eligible for the National Register.
Yeah. You guys found multiple palisades pretty much intact, right? Yep. I mean, that's very, I think, rare to find nowadays. But that's great. I mean, and it's great that you were able to take all that. And some people don't think about it like this, but geophysics, another application of geophysics or archaeological geophysics, right, is literally being able to nominate sites. Right. As opposed to excavation, if you can map an entire village and show that there's intact features clear, these are not natural occurrences. These are clear intact features. We already know from previous excavations significance of a site. This adds so much more to it. Put it in for nomination. I think a lot of people don't think that the geophysics can, or haven't thought about the geophysics being a primary data set to use for nomination, right? So I think that that's a great thing that you guys have done. All right, so we're going to move on because I know you were a little bit limited on time, but I have a question, quick. Then give the people who are viewing this and who are going to view the replay of it 2 actionable things that they can do when they approach a government agency that might be unique to dealing with government agencies that might help them kind of get people on board, soothe the process, or sort of manage expectations, of their prospective, agency client. What would be 2 things that you would give to those people?
Well, one is to know what agency you're dealing with, what agency are you interested in working with, understand what that agency's mandate is, what its legislative mandate is, understand its resource base. Is it a land managing agency like TVA or like BLM or like the Park Service? Or is it an agency that provides permits like the Corps of Engineers? Or is it providing federal funding like the Federal Highway Administration? Those are different legislative mandates, and those agencies will have different needs and different research agendas as well. So the first thing I would recommend for anyone is to understand what the agency needs, what types of archaeological applications it might want to apply, and go from there. Secondly, I would say it's good to be able to demonstrate how you in particular have used the instrument or other instruments in the past on other sites and what those results did in that particular case, so that you can illustrate to the federal agency or the manager how it can help them fulfill their mandate. Those are really the 2 most important things that I can say. I mean, education is always a part of that, but I think by demonstrating a case study or an example or 2, saying this is what we did on another site that's comparable, a comparable setting, a comparable time period, whatever it might be, and showing them what the results were and what the results could be if they wanted to apply it on their own types of sites, that's really the angle I see as being successful. Okay, so let's say you hypothetically have, those are 2 great things I think you said. Kind of go a little bit with the second one. Let's say you have some younger folks, or at least younger as far as their use of ground penetrating radar or geophysics in general, applied geophysics, and they're going to go to an agency, and let's say they don't have the 10 years back, right? Because you were at New South for I guess 8 or 9 years before that project began, and so you had a portfolio of projects that you've conducted over the last 10 years, or right? Well, I guess since you were at Georgia. But what about for people who might not have that depth, but they understand the equipment? Let's say, right, they are coming out of graduate school. They obviously have an academic background in it. They've done projects there, but let's say it's nothing that's on that kind of scale. So when you're looking to work with government agencies, how would you approach that if you were 8 years ago, right? And they come to you with this potential project. How do you deal with that? I guess, what are the options? Kind of the one thing, like, do you potentially help, hire somebody else out also to help you on it, do you think? Or if you feel like you have it down because you do have the background, even though you don't have the portfolio, do you show other examples of geophysics that have been conducted on similar sites that might have been published to say, we can do something similar to this, and here are the benefits, right? And so I guess the third point is you focus on the benefits of it as opposed to just, the image or the results or anything like that. Yeah, I would say, well, you hit on a couple of those points already, but yes, if I were, I guess the advice I would give to someone today is to get to know the actual individual managers at a particular agency with whom you might want to work, and talk to them. But I would explain to them what your background is, what your interest level is, and showing them case studies or examples of other sites that are not on their property or under their management is perfectly fine. And letting them know what the capabilities are. And I think there are enough people out there who will recognize that if they have a need for it, they will go forward with it. I mean, that's the experience I've had. It just takes time. It's not something that you can do overnight, and you have to make an effort to put the time in to build those relationships and see where it goes. Definitely. And I think some of that also is almost like, business 101. So you're an archaeologist, Shawn, but you're also, right, part of a corporation. I mean, you manage the office up in North Carolina, and relationship management, customer service, and all that, ties within. And that I kind of think speaks to your first point, which is,
understanding that specific legislative body, right? If we were talking about government agencies as potential clients, what they've done in the past, what their taste for this kind of stuff has been, what their exposure to it has been, before you ever go talk to them face to face or on the phone about it, is critical, right? And that's sort of like something that can be transplanted to whether you're dealing with a corporation, you're dealing with a non-for-profit, or you're dealing with a government agency. I think some people forget that sometimes, that yes, you're an archaeologist, or yes, whatever, you're a civil engineer, you're an environmental consultant, you're certainly a business also, and relationship building is one of the kind of core fundamental components to any successful business. So I think
absolutely
that the things that might be specific to government agencies is, luckily, you can actually view. I mean, a lot of them have right, they're kind of articles or whatever the case may be. I mean, like, how they've dealt with it, or what other projects they might have used it on in the past. And if they haven't, go in and kind of do basic needs analysis, as opposed to trying to ram geophysics down someone's throat. Find out what their needs are, and I guess show them the traditional method, and then show them how geophysics can actually enhance that, and maybe in archaeological contexts help preserve site with greater integrity.
Right.
All right, so then kind of transition. It is 2:41 here, and I know you have to get going soon. Can I get 2 more minutes with you?
Sure. Yeah, we're good. We're okay on time. Yeah.
Okay. So let's kind of move a little bit then into back to for young folks, or people just getting started out with ground penetrating radar, because at LearnGPR we train online and we train in person engineering companies all the time. We train municipalities all the time, who are the damage prevention departments, who are in charge of the utilities, do utility locating, and then have recently got a ground penetrating radar, but got a 2-hour training from the distributor. They go out to use it. It doesn't really work the same way as it did, during the sales process, and they're kind of stuck, right? And they don't know what they're doing. So I think some of them luckily find us, which is great, and we can kind of get them on the right path, but not everybody does. And what would you say to people who are new to GPR, who don't necessarily have a background in using non-invasive techniques? What would you say are the couple kind of pitfalls that most beginners go through, and what can they do to avoid those?
Well, those are great questions, and they are critical, because the instrument itself, talking GPR specifically, is not difficult to operate. Anyone can learn how to do that. You or myself can show someone which buttons to push and why, and anyone can figure that out. So it's not the technical part of it that I think is critical to me. It's understanding one's limitations, understanding what the instrument can and can't do, understanding the situation in which you're applying it. So if you're looking for rebar and concrete, that's a very different feature type than trying to identify a 200-year-old grave in a location that's unmarked. Those features have different contrast. They won't look the same. And we don't do utility locates, not because we couldn't find them, but because we're not interested, and we don't want to develop that kind of time to learn that. We focus on archaeological applications. But the other components are to put the time in. It really does take time to learn how to collect good data, to process data efficiently and accurately. And really the critical component is interpretation, to know what you're looking at, what types of features will be imaged in certain ways, and then how you can translate from anomalies into archaeological feature types. Or if you're interested in utilities, rebar and concrete will reflect very differently than a buried utility at 3 feet down. So you have to understand what types of contrasts there are and what types of objects in the ground you're trying to locate.
And certainly one of the things I would say, along with that, is a lot of times the frequency is so different between locating rebar versus locating a utility that's 3 feet down, that resolution is a huge difference. And so sometimes I find a pitfall is being people who are in concrete scanning, who are so used to using high frequency, high resolution radar antenna, begin to use lower frequency, lower resolution radar antenna for utility locating, because they're trying to expand their business. And I completely understand, and I commend them on it. I mean, I think you should use it on more projects if you can possibly use it.
Right.
But making that shift from understanding one frequency with one target in one medium, concrete, to another target, with another frequency antenna that's significantly lower resolution in a completely different medium, often much more complex and complicated, I think kind of gives people this huge gap that they're not ready for, right? Well, I can see all this stuff here, and I'm struggling to see it here. Or even if they can see something below the surface, you know, is it a utility or is it something else, right? And you know, and that's something that I've seen some people kind of stumble with, is when they go from one application to another and they're not ready for that shift in antenna resolution, because the data will look different. They're both hyperbola, you know, or whatever the case may be, you know, or they're layers. But the shift in the resolution, I think, is something that stumbles, you know, that some people stumble with.
Yeah. The last thing I was going to say on that subject, I agree with all those things you pointed out, is that putting the time in on the instrument is really critical. And I want to bring this full circle back to my first comments about my time at GDOT, where I had the opportunity to take that instrument out on a regular basis, not daily, but certainly weekly, and not only in my own projects, but with other folks as well, and the opportunity to make mistakes. But what it really took to become proficient with it was spending time on the instrument, collecting data, processing data, reprocessing data, doing multiple migrations because I didn't get a good one the first time. There's lots of that type of work so that I understood what the underlying principles are, but then how to apply it in a particular situation is really important. So time on the instrument, in my mind, is really the most important thing for me. And that's what
that's a great point. That's a great point. And I think, you know, a lot of the people I speak to often have years now of experience, you know, and they're able to look back at new companies jumping into the GPR services business and kind of shake their head sometimes. I think almost not recognizing, again, that was them 7 years ago, right? And it's easy to kind of to do that, you know. And so I think you're 100% correct that time on the instrument is invaluable and it's irreplaceable.
It is.
Now, a question I have for you then is, you know, where do you see time on the equipment, you know, compared to learning and understanding the conceptual, you know, pieces of the technology? You know, as you know, where does that kind of fit in? Right? I mean, do you think that that's something that people should use? Because obviously, look, at LearnGPR.com, right, one of our big points is educating people, giving them kind of continuing education, let them come back again and again to the fundamentals. Because it's almost like it's a longer learning curve, I think, if you're only on the equipment, right? Now yourself, you had some background in it. You know, you were trained when you were at Georgia, you know, adequately trained for sure. Sarah obviously has a huge academic background in it. You know, clearly trained in the fundamentals, in the conceptual and the theoretical. And for me, that's what I've had. And I've found it to be such a huge benefit to my own work as far as interpretation is concerned, right? Because, and fine, if you're doing concrete scanning and it's a rebar and your only thing you're looking to do is locate and mark it's here or it's not here, you can probably get away with less conceptual, just because the contrast between metal and concrete is so dramatic in the dielectrics. It's very easy to often see. But if you're going to expand out and do more complicated projects, like utility locating tends to be more complicated because the different materials of different utilities, different sizes, different soil conditions. I've always found that the theoretical background or conceptual background goes such a long way in letting people kind of get that learning curve faster, you know, early on. So when they're on the instruments, that's helpful. I mean, what do you think? And you can certainly disagree with me on this, but I'm curious what you think about it.
I do agree with you, Dan. It is important to have the conceptual background, but what I will say, yes, it's important. What I will say is that in my experience, there's no substitute for actual on-the-ground time, and that's because no matter how many case studies you might read about or how many publications you might look at, or if you go through Larry Conyers' book and see examples of a Roman villa in Petra, which he likes to talk about, you know, that's fine. The ground conditions in any particular circumstance will vary so far and so much from what you might read about that it will just be different. And and I learn every time I take the instrument out. I'm still learning. The conditions are never the same twice. And so yeah, it's important to have the conceptual background, I think, to get oneself off and running. But in my mind, and maybe this is a result of my own experience, I don't think there's a real substitute for having the practical, hands-on, in the field learning experience where you do make mistakes. And I still make them once in a while. I get mad at myself when I do it, but I don't make those same mistakes again. Generally, I try to learn from those. But I think it's important to have the hands-on time, just to familiarize oneself with the different types of soils. And well, it rained yesterday and we didn't finish our survey. Well, how does the rain affect what we're going to collect today? Do we need to go reset the RDP values, or do we need to reset the gains because we got 2 inches of rain last night? It's understanding those kinds of things that, yes, you can read about it and understand that water does affect the dielectric, But until you actually see it firsthand over the span of 3 or 4 days or 2 weeks or whatever it might be, and that how that dielectric actually does change as a result of either increased or significantly decreased moisture, you don't really know how you're going to approach those questions until you have to deal with it. And so that's where I think the conceptual background is really important, but there's no substitute for actually getting out there and experiencing on the ground real world conditions.
Yeah, I think you make a great point, and I completely agree. What we kind of promote is a combination of different kind of learning styles, right? Which is because I think they complement each other, right? Experiential learning and conceptual learning, I think, helps an individual who's starting out go such a long way. I think part of the issues with people who are starting out sometimes is that if they get no conceptual learning, they really don't even understand how the instrument works. But they know how to press the button, it turns on, maybe they can kind of amplitude it up a little bit, amplitude it down. They don't even understand what's happening to it. They're not really understanding what the background filter is doing, while they're collecting. And I think the struggle sometimes is a lot of folks, and less in archaeology, although it does happen with locating unmarked burials, but more in, I think, civil engineering and some other applications, utility locating, people are marking in the field, right? And so without going back and post-processing and literally just trying to do what you can in the field and never having any conceptual background, I found to be somewhat of the issue. So I completely agree with you. A little bit of conceptual with a lot of experiential, I think really helps people, going, in their career. I think it helps people, make some less mistakes. Or I would say this, even if you're going to make the mistakes anyway, I think if you understand what the mistake was, you can learn from it. Sometimes Absolutely. I think people make mistakes and don't even understand why the mistake was made. And I think it's harder to learn from those mistakes if you don't even understand what your mistake was. Does that make sense? So yeah. So that's kind of what we promote, right? Is kind of a combination of experiential learning and conceptual learning, kind of classroom style, right? Learning. And then one thing we're actually going to be doing in the future, going ahead in 2017, is put on live events and live training so people can get that hands-on, because people also want to learn it with their instrument, right? So if you can understand what your instrument's doing first in the classroom, then put your hands on it and understand what you're doing, I think it helps a lot in interpretation, post-processing, and things like that. But you're 100% right, and I think this is not just in GPR, I think it's across the board in anything. There's no substitute ever, I think, for experiential learning, right? I think the impact and the power of actually learning on the job is huge. And I think that the other, right on the flip side, is you can't get kind of like analysis paralysis, I guess some people call it, where you're just reading and reading and reading and reading, and you're still not even on the instrument, right? At some point you need to get on the instrument and go, make your mistakes and learn. So I completely agree with you. I think not being scared to make mistakes and being prepared to learn from the mistakes that you're gonna make, and this is out there to everybody, you right there watching on YouTube, is this is to you, is you're gonna make mistakes, right? We all do it. Look, I make mistakes. I think we make some kind of mistake in every single case, at least small, or in many cases, and it's the ability to learn from those or understand what you could have done differently, right? It might not be a mistake, but it might have been an alternative, and to understand, way to collect data or process it versus some other way to do it, which might have enhanced the project a little bit. Sometimes these are slight things that you might still have a successful project, but learning from, by going over your process again and again and again, I think is an important thing. So you're all going to make mistakes out there. We certainly made mistakes. I've made plenty of mistakes. And Shawn, has admitted now on air, that he has made at least one mistake in his life. So, so you guys will make it, but heed Shawn's advice, which is don't be afraid of your mistakes. Make your mistakes and learn from your mistakes, because the only way to get better is to get out there, get your hands, on the equipment, go. Learn at home, learn in the office, learn out in the field. Learn in the office, learn out in the field, and really be able to understand what you're doing out there to get a better handle on your interpretations. Because the major thing, really, at the end of the day, is your interpretations. It's what can you learn from the data. It's usually not about making a pretty picture. Although I will tell you, Shawn's picture that he made from the TVA project in Hiawassee Island is pretty. I want to frame it and put it on the wall. It's really, really gorgeous. But most projects, and Shawn, you can, I think, back me up on this, most projects don't look that good, right? Most projects don't, and it's not about how it looks, it's about what information that you can glean. At least that's the way that I've always sort of, looked at it. What about you?
That's right. Yeah, I agree. Yeah, interpretation is really it's the linchpin for archaeological applications, and knowing, not always knowing, but having an understanding of the archaeology in the ground so that you can develop expectations for what types of things you should be looking at, and then having the experience with radar in particular to know how certain features will be imaged and how they should appear in radar data. All that helps.
Absolutely, absolutely, and I think kind of on that final point, then, because I want to get you out of here and get you going, and I appreciate it.
Sure.
But kind of taking that deductive approach, right? I think that's where the conceptual comes in. Being able to, in your mind, have a cognitive map of what your features or targets or subsurface might look like based on what you know, helps you, I think, interpret data in the field and then in the lab afterwards. So it comes down to the interpretation, right? It comes down to the interpretation, and that, I think, ultimately is the mark of success for the project. So we're going to get going now. I'm going to let Shawn go. I appreciate all the time that he had given us. I hope that you guys learned something from him. I've learned something from Shawn, in this afternoon. It's a ton of valuable information, a bunch of nuggets that I'm actually going to take now and going, especially when I have to deal, because we still survey too. So when I have to deal with customers and clients and agencies, I think he makes some really important points. We can all do things better, like learn about what your customer wants and needs and what their exposure has been before you really get, into the crux of what you can do for them or how GPR can, add to their project or make their project more successful. So first of all, if you're on YouTube and you are watching this, click the subscribe button below. This is the first of many. I don't even know what we're going to call this, but if we do this as a regular thing, Shawn is the first in the GPR hot seat or whatever. But maybe that's a good name. I like it. So Shawn is the GPR hot seat, and we really appreciate his time. Right, he's again from New South Associates up in North Carolina, although they have offices everywhere. But if you like this video, subscribe. Go check out New South. What's their contact information? So just in case people are interested in projects, they can get in touch with you.
The website is www.newsouthassociates.com. That's NEWSOUTHASSOC.com.
Cool. So definitely go check them out. Go follow them on Facebook. I mean, I follow them on Facebook for a long time, and they always, put out really interesting things that they're doing both in the field, at conferences, and just overall good information. So follow them at Facebook as well. And we appreciate your time. I appreciate your attention. So thank you guys so much for tuning in. Shawn, thank you again for coming on, today as our first guest of all time. And I do appreciate all the information you gave from your 10 years plus career in ground penetrating radar and geophysics, as applied to archaeology. Like I said, I have admired your stuff for a really long time, and so I'm glad that we got to catch up in front of the world. So that's always good. If you have not done so yet, go to LearnGPR.com. You can put your name and email in and get our free training course. And so if you have questions about anything Shawn was talking about today or that I was talking about, and you want a little more information about the basics, go to LearnGPR.com, put your email in, and sign up for our free training video. It goes over all the very, very basic fundamentals that you need to know about GPR. So thank you again. I appreciate it, and I will see you all very soon.
That's great.